Alright, minimum moves to reach target in grid. Right, we are given four integers sx, sy, tx and ty. We are at sxy and we need to reach txy, and the jump that I can make is to the left, I mean to the right or upward direction by m steps, which is based on the point from which I'm jumping, that is xy. The max of xy will be m, and m is the jump I can make up or right, and I need to return the minimum number of moves, right, to reach that point. Otherwise, if we can't, then we return negative one, right? So essentially, we are given 2 points, and we are either jumping like this, 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 right? Or some other possibility, right? From here, we don't really have a next possible point that I can safely or greedily tell that this is the point that we choose for getting the minimum number of moves. But that's not the case for the reverse paths, right? Reason being, from here we can technically say what is the previous point greedily, and the reason is because tx and ty are 2 points, that's the destination, right? In that case, let me consider uh, the previous 2 points be px and py, all right? And let's consider if tx is greater than ty. That means I'm considering the possibility that I made a right jump. That means my previous point will be somewhere here, right? This is px, py, right? Because I considered this case to be tx is greater than ty, that means a right jump is a valid possibility, right? Then what that px, py could be? Well, I can either add py or px to this to get tx, right? That means I can either add px to px, making it 2 into px, right? Or I can add px to py to get tx. Since we are only considering a right jump in this case, I can safely say that py is equal to ty, right? Because we are not changing the y coordinate. So one possibility will be tx is equal to 2 into px. But this will only be true if it's a valid possibility, right? That means if px was indeed greater than py, and that is only true if or I can say that I want this to be true, but this will only be true if uh, it could be probably it's getting messy, but since tx is equal to 2 into px, right, and I want px to be greater than py, which means I want px to be greater than py, right? Or I can say that I'm basically saying that tx by 2 is what px is by 2 is greater than py is equal to ty, that is ty. That means tx is greater than 2 into ty, and this also means that since there can't be floating values, right? That means tx must also be a factor of 2. It should be divisible by 2, and tx is divisible by 2. So these are the two possibilities for this to be a valid jump from the in the reverse direction from the destination. All right. So if this is not the case, that means the other possibility is uh, px, or actually py is greater than px, right? That means else other possibility is so else the other possibility will be that px is smaller than py. That means tx minus py comma py was the last point, or since py is ty, this is the other possibility, right? And similarly I can just copy this and say that it's going to be the exact opposite for this condition, exact opposite. Lastly, the only case I'm missing is if tx is equal to ty, right? I'm sorry if this is messy. I'll write the code and then probably it will make more sense. So if tx is equal to ty, that means uh, that means basically if both are 0, both are 0 and both sx and sy is also 0, or the only other possibility is, since we can jump only in one coordinate, that means if tx is equal to ty, I am going to make only one of them 0 for the previous point. That means it's either going to be 0 comma ty as the previous point, or tx comma 0, right? That's the other possibility. So let's code this up. I'll code it in the recursive way. So if the base case, that is sx or ty is less than sy, in that case we have run across the only possible point that we could, that means it's invalid, we can't reach. If both are equal, in that case return 0. Now comes the three possibilities. Ty is greater than, or let me write it this way, else the other possibility. So here if tx mod 2, or sorry, if tx is greater than 2 into ty, that means I can half it, but before halving it I am going to check if tx mod 2 is equal to 0 or not. If it is not equal to 0, then return negative 1 from here. uh, Otherwise I'm going to get the next move, right? Let me call this sub answer, right? In this case this will be called recursively but with previous points. Sx comma sy will stay as it is. Tx by 2 comma ty, right? And at this point I can just check if sub answer is coming out to be -1. That means from here if I return sub answer and that is -1, then I can return -1. I don't need to, I can basically prune this early because it's returning -1. Otherwise I will increment my answer by 1 because I've used one move. Alright, okay. Else, this means that py was greater than px in the previous point. That means I am going to uh, basically do the exact same thing, but this time not by 2 but subtracting ty, and that's it. Since we are going to reuse this function a lot, we can also create a different function, but let me do it this way for now. So this will be the exact same thing for this condition, but here it will be ty and tx. So let me, this will be tx, or actually this will be divided by 2. This will be subtracted by tx. This will be ty mod 2 not equal to 0, and I guess we are good. Now last thing is the else condition. The else condition is basically if sx and sy are both 0, right, and uh, if any one of them is not 0, that means both are not 0. So I can just basically check that if tx is not equal to 0 or ty is not equal to 0, then this is an invalid case. Can return -1 from this point. Otherwise, if sx is equal to 0, that means I can make tx to be 0 for the next move, right? Uh, Let me basically copy this, right? This will be 0 and this will be ty. Else, if or I don't need else, if sy is equal to 0, in that case I can do the exact opposite because one of them can only be 0 at this point, since we are jumping only right or left, or I mean right or up, right? And lastly we can return -1 if I don't think this is ever going to be returned. Let's see, this is ty not t, not just y. Okay, this works. Let's submit this. Alright, this works. That's the fourth question. Thanks.